We're still working out of our lab workshop, and this next set of discussions, lectures, lab wrap-ups is on messaging. In other words, communication, read-write, communication between processors. And in this lab, we took a variety of hardware, some different platforms, and we had them communicating with each other. Now, for you to do these lab projects, you would have to have at least two processors. I mean, you can't have one processor talking to itself. So these lab projects used to be in the advanced manual. They're not in the advanced manual, but we're going to include the discussions anyway, because even if they were in the manual, if you don't have the hardware in order to connect them up and do CIP messaging, it wouldn't have done you any good anyway. So what we're going to do is we're going to discuss the lab projects, and we think you'll glean some good information from watching these. So let's start with the first discussion on messaging, message instructions. Welcome to the next lab discussion video that supports an introduction to RS5000. These lab projects can be found on approximately pages 157 through 183 of this manual. These numbers could shift some as we change things doing various printing. And this is from Volume 1 of RS5000. Volume 1 of the first in a series of the Complete PAC Learn series. The lab discussion was broken up into three pieces because of the length of it. After you do this part, then find part 2, and when you're done with part 2, find part 3. Explicit messaging between two processors that both use the Logix engine and another processor from an older family. And the hardware that we're going to work with, we have a 1769 L35E. We're going to start with that. And the 1769 family of Compactlogix was made up of an L20 series and an L30 series. This is an L35E, and if you look at the front of the processor, which is the leftmost module, you'll see a key switch. Below it you see an Ethernet port, then an RS-232 port, and then just to the right you see a slot for a memory card. Starting from the left, you have an end cap, then you have the processor, then you have a power supply, a 1769 power supply, 3 I/O modules, a DeviceNet scanner, and another I/O module. Not exactly the hardware configuration we're going to use. It's just a picture I grabbed off the web. But we're going to have an L35E, as you see, a power supply, and then we're going to have a digital output module, a digital input module, and a combination analog input-output module. So we only have 3 I/O cards. Then we're also going to add a 1768 L45. This is the newer, but not the newest family of Compactlogix. There's actually 3 basic families, 1769, 1768, and then a newer one that I call L1Y, L2, L3. They are supported only on version 21 and higher of RSLogix 5000. These two families of the Compactlogix platform are supported by the earlier versions of RSLogix 5000. Now the L45 there, which is on your right, it begins with a power supply, a 1768 power supply. So if you're buying this stuff on the network, make sure you pay attention to what you're doing, because the power supply for the 69 on the left will not work with the L45 or the L43, which is over on the left. So you need to keep your part numbers straight. Everything over on the left is 1769. Everything over on the right is 1768 until you get to the processor. And then if you keep going to the right, that's 1769. So you use the same I/O cards on both of these platforms. On the right you have a power supply, then you have an Ethernet bridge. There's a difference between an Ethernet port and an Ethernet bridge. And you see right at the bottom of the face it says Ethernet IP. And then you have a Circos card, which is for motion control. It's a fiber optic interface between the backplane of the L45 and Kinetics or Ultra type Circos motion drives. And then you see the processor there has the key hanging out of it, and right below the key is an RS-232 port, and kind of blocking the view of the key and the 9-pin sub-D shell for RS-232, you have a little snap out cover that covers up a memory card that you can slide in there. And these are standard memory cards. These aren't anything special. And then continuing to the right, you have a 1769 I/O modules. You use the same I/O modules on both of these Compactlogix platforms, but the part numbers and the power supplies are completely different. So the L45 does not come with Ethernet, but the L35E does. So these are the two main players in what we're going to do in this lab. However, to make it interesting, we threw in something from an older platform. I have a 1763 L16 BWA, which is a Micrologix 1100 that uses 115 volts for power and has DC inputs, and I don't know if it's relay outputs or DC outputs. I don't actually have anything wired up to the inputs and outputs of this controller. I'm just using this to demonstrate how to communicate from the L35E or L45 to the Micrologix 1100. So we will write to the 1763 Micrologix 1100 and we will read from it, but we won't initiate any messaging from within the Micrologix to the Logix engines of the L35E and the L45. There's conversation is what we call this controllers in conversation, the lab. And conversation between controllers is a bit of a stretch, considering that conversation is not just sharing data, although that usually occurs during a conversation. But since we have, on occasion, throughout the lab exercises, personified our controllers to allow you to be first person as a controller in how you see the inputs and outputs, the communications and the data, we will continue to take license here with that approach. In addition to personifying the controllers, we will create tag names that lend themselves to that idea of personification and are a little more lengthy than normal for the purpose of clarifying the who and the where within the tag database. All controllers the world over have at least one communications port. At the least, they have an RS-232 electrical interface, and then they don't all have the same protocol though. So RS-232 is not a protocol. It's electrical specification, and it's usually represented with a 9-pin sub-D shell. And this connector will be somewhere on the controller. However, these are beginning to disappear from controllers in favor of USB 2.0 ports and or Ethernet ports. I said all controllers the world over have at least one COM port. They can communicate with each other. There are many methods of communication between controllers. If the controllers are not from the same manufacturer, like these are, you can still communicate between them, usually with a myriad of electrical adapters and third-party communication applications that bridge the gap between incompatible protocols and hardware. I would almost defy you to find an example of two controllers that cannot communicate by some convolution of devices and software. Of course, that's assuming they're not broken, that they do power up and all of their features are fully functional. If you have an RS-232 port on each of any two processors, you can find some electrical interface to put between them, even if it's a computer with two RS-232 ports, and then write your own code in between them to do the communications. This means, of course, that the communications is going to be the most difficult and most expensive to implement of any possible scenario. And this scenario is the least robust and not at all deterministic. Because to be deterministic, not only does the protocol have to lend itself to determinism, but the hardware, the electrical interface, has to be very robust and bulletproof. Now, any hardware salesman worth his salt, of course, will tell you, oh yes, our hardware can communicate with theirs. You use X brand, we have Y brand. Yes, they'll communicate. They both have RS-232 ports, or they both have Ethernet. Now, what he said is not a lie, but the answer is also true to the question, can you fly to the moon? Well, yes, you can fly to the moon, but it's not a very practical course to take. So the solution, when you have controllers that are not from the same manufacturer, is going to be a convolution of adapters and software, probably without usable support. Keep in mind that when you mix vendors, they all tend to point at each other when it doesn't. Well, it's their fault, you know. So you say, well, I'm having problems, and if you're using brand X and brand Y, brand X says it's Y's fault and Y says it's brand X's fault. Occasionally find a good tech support person who feels sorry for you and figures, well, I'll just make him a customer of mine, and he helps you fix whatever the problem is, whether it's his problem or not. That's the first classification of communication between controllers, if the controllers are not from the same manufacturer. If the controllers are from the same manufacturer but not from the same platform, which is what you have right in front of you right now, the L35E and L45 are basically from the same platform. They both run the Logix engine, but the one down below does not. The one down below is supported by RSLogix 500, a completely different programming software than the one above, although all three of these are Ethernet. So in that sense, they are very compatible. If you have two controllers from the same manufacturer, but they're not the same platform, then it behooves that single manufacturer to provide you with the interfaces, both any required adapters and the necessary protocols. This means of communication is time-consuming to implement, mainly because it requires access to your memory, your skill of recall when configuring the instructions to communicate, and requires knowledge and access to of more locations in the program code. So the solution to controllers from the same manufacturer but not the same platform is usually message instructions and communications adapters, usually with some support. Now in this case, we have two controllers from the same manufacturer, but really not totally the same family. The 1769 processors and 1768, they're both Compactlogix, but they're two different platforms. Because they are both the Logix engine, the communications are inherent in every design consideration, and as a result are native to both hardware adapters, memory data structures, protocols, and of course the icing on the cake, as they say, is the integration into the programming platform, which in this case is RSLogix 5000. The programming software is able to access the far reaches of the realm hardware network structure because they are basically both of the same manufacturer and of a similar platform. So the solution here is something called producer-consumer. Now we're not going to do producer-consumer in this particular lab, but producer-consumer is so simple that it requires almost no support at all once you learn it. Now the scope of this lab project falls within the second two categories. Controllers are the same manufacturer but not the same platform, and we'll do that towards the end of the exercise. But primarily, most of this lab is going to involve communications between the L35E and the L45. Now, here's our three players again, and of course, a fourth player, and then a fifth, which is a Ethernet switch. Nice thing about a switch is it's not real fussy about your cables. If you were going directly from your laptop to any one of these three devices, you would need a crossover cable, which on my website, www.plcprofessor.com, if you drill around in there, you'll find some talk on crossover cables versus patch cables. But anyway, with a good switch, it doesn't matter. And so we're going to hook up cables from all four of these devices. L35E, we're going to call that one, we're going to refer to it as programmable automation controller L35E. That's probably what we'll name it in our procedure. And then of course this one we'll call it PAC-L45. So we're personifying. We're not going to say the PAC-L35E or the PAC-L45. We'll just say PLC-L35E and PAC-L45 as if we're saying Jim and Pamela. Okay, so we're personifying them, so we won't use the controller. We'll just say PAC-L35E, etc. And then of course the Micro 1100. And sometimes we'll refer to him or it as Uncle Micro 1100 because it's an older platform. And then of course we don't want to forget about you. All four of you all are plugged into each other by way of this Ethernet switch. Okay, now we have RSLogix 5000 open, and we need to create initially two projects, one in L35E and the other in L45. We're going to start with the L35E. In the manual, I showed you a side-by-side screen capture of the L35E and the L45. I also showed you the communications tree from RSWho and RSLinks that showed the Ethernet IP addresses that we were going to assign. The laptop is at 192.168.1.100. The L35E is going to be at 111, and then the ENBT, which is attached to the L45, is going to be at 99. All the same subnet. The subnet is 192.168.1. That's the subnet. Then the Ethernet IPs are 99, 100, and 111. So we have RSLogix 5000 open here. Let's create a new project. File, New. It's going to be an L35E version 20. And it's going to be named PAC_L35E. And we want to make sure that we put it in the appropriate folder. So we go to Desktop and pick, there it is, right there, Learn RS5000. Select OK. That way our projects will be saved in that folder. Now you can pick any folder you want. So we click on OK. We give it a second to create the project. And the first thing we're going to do is add some I/O modules. I'm going to show you first that it's empty, then I'm going to go add the I/O modules, but I'm going to pause while I add the I/O modules. You don't need to see that again. You've seen it quite a few times already in this series. Now, wasn't that amazing how fast I put those I/O modules in there? You recognize these three from previous labs. So the first thing we want to do is we want to configure the Ethernet port. So we go to Properties for there's a little daughter card there. You see it, 1769 L35E Ethernet port, local ENB. And we're going to give it an IP address of 192.168.1. Trying to remember now what I gave it. I look at my cheat sheet here. 111. Apply and OK. Now our Ethernet port is configured. Our second conversationalist, I'm going to minimize this project and open a new one, but I'm going to pause until it's open. In the past, I've been closing the quick start screen before you saw it, but this is a feature of RSLogix 5000, and you can open an existing project, create a new one, open sample projects, open sample vendor projects, and you can also go to documentation. I'm going to close this though. I just wanted to show you that it is there, and if you have a full loaded version of 5000, then you're going to have the quick start page. So I'm going to close that. File, open, file new. File new. Only we want an L45. So that's going to be further up here. Whoop, there it is right there. L45, version 20, PAC underscore L45. And we want to save our projects in the same place that we saved the other ones. And scroll down to Learn, RS5000. Now we're all set. Okay. We already have one in there by that name. So I'm going to say no. And I'm going to put an X after this one because I don't want to write over the top of what I was doing. So in your lab, you didn't do this. You didn't put in an X. Okay. It's creating the project. And we're going to do the same thing. We're going to go add I/O modules. I'm going to pause while I add the 1769 I/O modules, but I'll come back before I add the other modules. Okay, now we're back. We've added the I/O modules for the 1769 bus, the discrete modules, and the analog. Now we're going to add the Ethernet module. So we could uncheck everything and then check communication. There isn't much, ENBT. And I'm going to assume it's 4, but I'm going to disable the keying anyway. And I think I called it my ENBT. And it gets configured at 192.168.1.99. Again, the first 3 octets here are the subnet. This is our actual network. This is not an Ethernet class, but if you were to look at the subnet mask, it's 255, 255, 255, which means the first 3 octets define the subnet, and because the last octet is 0 in the subnet mask, that means we have a network of 0 through 255. Of course, we don't use 0 and 255, we use 1 through 254. And that's in slot 1, so we'll say OK. Now we also have another communication module that we're going to throw in there, even though we're not going to use it, just so it doesn't complain about the configuration. And it is the only motion module that's available, and you can have 2 of these. Now in this case, we're only going to use 1. And we're not even actually going to use it in the lab, but it's part of the hardware configuration. And I think I called that something crazy like making motion, or actually I don't even show it in the configuration, but I'm going to throw it in there anyway. We'll just call it making motion. And it's in slot 2. We're going to disable the keying. Okay, now we have our 2 communication modules, the Circos and the ENBT. The ENBT is the one that we're the most concerned about. Now we're going to go back to the L35E, so we'll save this. Minimize it. And then bring back up the L35E. I don't think we saved it, so I'll save it. We're going to go to Ethernet. In all of the processors that use the Logix engine, if you want to set up communications with another processor or with another device, you have to add it into the I/O configuration. So we're going to go to Ethernet, right-click, New Module, and this is the L35E, and we want to connect to the L45. We're going to uncheck, then check communications. We're going to go to a 1768 ENBT. Okay, this is the only Ethernet module that you can use with the L45. So we're going to select that, create. Again, we'll let it be Rev4, and we'll call it remote. remote ENBT. Even though we already defined its IP address, that was when we were actually configuring the 1768 ENBT in the L45 project. This is the L35E project. It doesn't know anything about the L45 project, but in order to get it into the I/O configuration, we have to identify its IP address, which is 192.168.1.99. It's in slot 1. Okay, now the reason that you have to include that is because you're creating a path in the I/O configuration. You see down here, we're adding it into Ethernet, and there you can see we've got the 1768 ENBT. Now it's popped in there, and we have to tell this processor, the L35E, that it's at IP 192.168.1.99. But then that only gets to the backplane. We want to actually go to the processor, so we tell it's in slot 1. Okay. We want to go back to our L45. So here's the path from our L35E processor, goes by a way of Ethernet to the ENBT that's in the other PLC. That's, you can see right there, is at 0.99. So it's at network address 99. And we could go and continue on creating paths to other devices, but we don't need it. So we're going to save this. Then we're going to minimize it and bring up the other processor. This is the L45 now. See, PAC L45, little x because it's a copy. We're going to go to Ethernet, new module. Now we're going to add a, we'll click on communications, and you can see a bunch of devices. Okay, now we're going to go click on controllers and unclick communications, and we're looking for L35, whoops. We're looking for the L35E Ethernet. There it is right there. So if I unclick communications, it's not in there. Okay, it's not treating it like a controller, it's treating it like a daughter card on a 1769 L35E. So there it is right there. There's quite a few of them, so it's easy to jump right across it. Okay, it is version 20, remote L35E. And again, we have to say what subnet and network address it's at, 192.168.1 dot, and I don't know why I don't have these memorized, but 111. And we're good. Okay, so now we have, I'll spread this out here. So this is the L45. See up here, PAC L45. Okay, and we've created a hardware path in our virtual hardware platform here, our hardware image. We've created a path from the L35E over, this is the L45, from the 1768 ENBT through Ethernet over to the L35. That'll give us access to the controller to do communications. If I bring up the other project, the L35, I'm sorry, the L35E, see L35, whoop, how'd that 4 get in there? I'm going to have to go change the name on that. Fortunately, we haven't downloaded this yet, so I fat fingered that. I'm going to delete. Maybe that's why it didn't come up and say that it already existed. Save this. Okay. Not to be confused, I'll just slide this over. These are our two projects. This is the L45 and this is the L35E. Our path from here to here goes from this processor through Ethernet over to the 1768 ENBT, which is right there. There's a 1768 ENBT. And from over here, we go from the processor to the ENBT over the backplane, through Ethernet over to the L35E, which is over here. Now that was the easy part. Although it is not obvious that this is required, it helps to diagram your communications paths and targets well in advance, including any IP or node assignments. Now you see I had to fumble a little bit to remember who's on first and who's on second, what IP addresses belong to who, and I do have a little diagram. I wasn't looking at it though. Great, we have controllers that are capable of talking and a means or path of communications. However, they do not have anything to say and no method of initiating conversation. So we're going to stop at this point and start a new presentation because we're well over a half hour now, well over 30 minutes, and we want to keep these at 30 minutes or less. That finishes part 1. Time to move on to part 2. We have lots to go. We're barely into the lab. We're on page 6 out of 25 or so pages. So we'll try to keep these at 30 minutes. Occasionally I get a complaint that I'm too long-winded and I go through everything in too much detail. Occasionally I get a complaint that I'm going too fast, I'm skipping details. So my bent or lean is towards the slower learner, the novice or the beginner. And if you're already well advanced, well, just kind of fast forward through here and glean what you need and go on to part 2. So thank you for watching part 1. Make your way to part 2.